The new Siemens SGT 750. Proven technology, perfected results. Count on it.
When we started to develop the SGT 750, we carried out a comprehensive survey where we asked our customers what was most important for them, both in terms of cooperation with us at Siemens and also the technical solutions realized in our turbines.
Customer value. Uptime.
Performance.
Green power. Flexibility.
It was clear that the most important aspect for everyone was reliability. Our solutions offer maximum uptime. The turbines themselves are of quality design and are constructed in high-quality, robust materials down to the smallest detail. They're also extremely service-friendly. Gas turbines from Siemens are renowned for the peace of mind they give their owners. An operational disturbance, whether planned or unplanned, always involves a loss of income for our customers. So we set up clear targets for operational reliability. One target was to offer our customers a maintenance solution of only 17 days and 17 years of operation. We achieved that goal partly by building in optimal serviceability right from the very beginning of the design work. For example, we have used advanced 3D visualization techniques to test and improve the serviceability on a 1-to-1 scale. It was also clear that we needed a new power output. There was quite simply a gap in our range. Now we have filled that gap with an extremely efficient 37 megawatt machine and with technology that keeps emissions to a minimum. All this, high efficiency, low emissions, high reliability, and simple maintenance yields a higher lifetime value for the customer. Our turbines are there to deliver not only power, but a source of income. We want our customers to sleep soundly at night without worrying about the continuous operation of their gas turbines. Quite simply, you can count on them. Every part, every detail in the SGT 750 turbine has been designed for maximum customer value and profitability. We have aimed for the perfect mix of high efficiency, low emissions, and maximum reliability.
Let's have a closer look at the details, starting at the very beginning with the rotors. The rotors incorporate the heritage of Siemens electron beam welding. The single rigid compressor rotor body ensures reliable, stable, and uniform run-up in hot or cold conditions. Axial blade attachment grooves allow blade replacement without rotor removal. The turbine discs are bolted to the compressor rotor and supported with mineral oil lubricated long-life tilting pad bearings. The balancing planes allow field balancing on-site without disassembly.
Even in the early engineering phase, we can design in future maintainability and serviceability.
The compressor is a 13-stage axial flow compressor with a 24-to-1 pressure ratio. It offers a controlled diffusion airfoil for high efficiency and 2 variable guide vanes for optimized performance, even in the most extreme conditions.
The combustors are the 4th generation of DLE burners from Siemens. Here we make maximum use of the fuel input while ensuring that both NOx and CO2 levels are kept under control.
DLE, dry low emissions combustion, is used in 100% of all SGT 700 and SGT 800 installations, and since 1990, it's also the standard combustion method used in the SGT 600. The DLE turn-down capability enables the use of large single turbines replacing multiple small units, allowing the same operating envelope. It offers robust and stable operation with dual fuel online switchover capabilities.
Following the flow direction, we come to the compressor turbine, which is based on years of experience and expertise. Durability and wear resistance are the criteria here. We added infrared cameras to monitor detailed temperature measurements. The cameras detect the slightest change and enable us to carry out the right actions at the right time in the event of an irregularity. When it comes to the power turbine, it's important to be able to optimize the settings for each individual customer. The turbine has to generate the optimal amount of power, whether it's located in Arctic conditions, in a temperate climate, or in the middle of the desert.
The free power turbine is a two-stage high-speed module nominally running at 6,100 RPM. It's equally suitable for mechanical drive application or with speed reduction gear power generation. The free power turbine makes the unit an excellent choice where grid requirements call for maintained power output in the event of frequency drops. It can be optimized for all ambient conditions, Arctic, temperate, and tropical climates.
The package is assembled as a unit on a single lift frame with a divider between the turbine itself and the driven equipment. For onshore installations, generators and other equipment can be mounted on a separate concrete foundation. Our aim with the SGT 750 package was to develop a compact and easily assembled unit. We achieved this by developing a generic driver which can be used both for single lift applications or onshore installations, where it can drive either generators or gas compressors. Inside the package is the lube oil system, the start motor, gas fuel system, purge system, secondary air system, and compressor wash. To minimize the amount of time on site, we test all the equipment before it's delivered. Outside the package, we have the liquid fuel system, water injection, and fire extinguishing system. All our turbines are adapted in a cost-efficient manner for each individual customer's needs and background, so that we can provide a complete solution. Important for us is that we can offer the customer a complete concept at an early stage. The SGT 750 has been developed to suit a number of different applications, everything from mechanical drive to power generation, including combined heat and power. Both gas turbine and the package can be adapted for the specific application of the individual customer, enabling him to gain maximal profit from his project. When it comes to serviceability, the SGT 750 is quite unique. We can offer our customer extremely high uptime with as little as 17 maintenance days during a 17-year service cycle, if that's what the customer wants. We can replace the entire machine in 24 hours to reduce downtime to a minimum. But the normal service concept is unique in itself. It's based on a smart combination of remote monitoring and analysis of operation data, quite simple service routines pursued by the customer himself, and annual service visits to check the health of the turbine with the help of infrared cameras. This way of working has enabled us to offer really long maintenance intervals. 4 years of operation before we even need to open the machine is just the start. This gas turbine just goes and goes. The few times it has to stand still, the design is so planned that work goes as rapidly and smoothly as possible. And when the work is done, the turbine is going at full power again within 10 minutes. And as part of Siemens, we can also offer a number of extended scope solutions, which can encompass everything from fuel systems to generators, switchgear, transformers, or boilers. This delivery from a single source is a security package for the customer. Different concepts are available, of course. A customer may operate only half the year, probably during the winter, and in this case, all service can be done on site, using the customer's own personnel. Service alternatives are many, as varied as our customers.